Hey everybody, section 9.3, we are going on to our third kind of rigid transformation, and that is rotations. Alright, our important terms are what is a rotation, we're going to talk about the center of rotation and an angle of rotation. Alright, let's get right into it. So a rotation of x degrees about a point Q, now this point Q here is called our center of rotation, okay? So we are going to rotate x degrees and transform triangle UVW into U prime V prime W. Every point on the original pre-image on UVW gets rotated the same number of degrees. So I've drawn the little red lines that show the connection between V and V prime. Okay, and I'll show you a little bit later. Anyway, a rotation involves a degree measure, x degrees, and a center of rotation. In this case, it's called Q. All right. Transformation of a rotation has these two properties. So the image of Q is itself. Okay, it doesn't change position. But any other point, like take for example point V, angle Q, VQ, V prime is equal to x, okay? Angle VQ, V prime would equal x, okay? And what else? Oh, the second thing, the distance QV prime is equal to the distance QV. So these two lines have to be congruent and move in this direction, or in the direction, sorry, move usually a positive degree measure is in a counterclockwise direction. All right. Anyway, the lines are congruent, and every point rotates by that same amount x. Okay. So let me reset this, and just again, so you trust me, if we were to look at, see if I can alter this. Okay. We were to take these two red lines out, I will show you exactly what I'm talking about. So we just saw V prime, all right, but rest assured that if I were to draw dotted lines, okay, leave those orange things out. So we had the lines between V and V prime. Know also that if I drew those red lines between, say, QW and QW prime, know that this angle would also still be x, W moved the same amount, and that these two red lines would also be congruent. Alright, so there's the line showing WQW prime, and going back to our original picture, here's VQ, prime, same angle for every point. Alright, next, that measure x degrees, that's called the angle of rotation. Okay, and the rule we write, okay, it's a rigid transformation, and we use this kind of a rule. Okay, we use a little r to mean it's a rotation. Right here, we'll put the angle of rotation. Right here, we put the center of rotation. So what this rule means is that it's a rotation of x degrees about point Q of triangle UVW, and we're going to get out triangle U prime, V prime, W prime. That's our notation for writing a rule for a rotation. All right, moving on. A couple pictures, just hope you see it. Here's the image, or here's the pre-image of Yuma. All right, every point I've moved about 90 degrees. So see the purple lines, the orange lines, and the green lines, and we find the corresponding point after a rotation of 90 degrees about point Q. Next one, here's a 180 degree rotation. Okay, every point is 180 degrees rotated around point Q. Pre-image image. Finally, know also that they can overlap. If I put point Q in the middle, I couldn't label it, but here's about a 60-degree rotation. Notice how every point, say the top of the bottom of the Y, is rotated 60 degrees to go from the blue figure to the red figure. Put a little mark in there just to show you. Okay, so 60-degree rotation from here to here, 60-degree rotation from here to here, 60-degree rotation from here to here. Okay, every point. That's how it works. So, kind of problems we're going to have. What are the vertices of triangle PQR after a rotation of 90 degrees around the origin? Okay, all right, so here's our thinking. Let me make this in red. Here's our pre-image. Now, we know that the angle 90 degrees has to be maintained. Okay, so my origin right here, if I consider a line from the origin to Q, I know my line to QP must be, to Q prime must be just as long and perpendicular, 90 degrees, right? There it is. Okay, so this will be the direction I go in order to get Q prime, right there. All right, we'll do the same thing for P prime. And let me also point out on this one, know how I know the distance is the same? Well, because basically I'm using the Pythagorean theorem. Okay, show you what I mean. Okay, so from P, I go to the origin, and I know I've got a line that went down 3 and over 6. So I know I'll have the same size hypotenuse if I draw another line that's got a side of 6 and another side of 3. Okay, but this one I know has to be perpendicular to that one. So I'm going to go this direction and go over 6, or yeah, over 3 and up 6. And there's my line that shows me where I'm going to get P prime. Right, P prime. Okay, let's move that out of the way now. And do it one more time for R. Okay, basically I know I'm going down 7 over 5. And I will have the same size line when I make a perpendicular line that is over 7 and up 5. So right here is where I'm going to draw R prime. Now I can move the red lines out and connect those dots, and I have created my 90-degree rotation of PQR to make P prime, Q prime, R prime. Now, you can always do it by counting the figures and making those points up again, but I want you to notice something. For any point, notice how we change the x coordinate on each point to what corresponds to negative y x. So in other words, look at Q. That's at 3, 1. Well, when I did the rotation, I ended up with negative 1, 3. Okay, so I took 3, 1, and I changed it. Took y, made it negative, and put it first, and x came out the same and listed it second. So for point P, which is at 6, 3, we do the same thing. I take 6, 3, and I change that to negative 3, 6. And bingo, that happens to be where P is. Okay? So know that that holds true no matter what. R changed from 5, 7 into negative 7, 5. Okay, that's a good rule, and it always holds true for a 90-degree rotation about the origin. Okay? Let's go on. 180 degree rotation. Okay, now we know we're going to make a line, make them red. Okay, that's going to go through the origin and basically cover the same distance, right? So I'm going to go from Q, once again through the origin, and now for 180 degrees, I know I'm just going to keep on going the same distance. This went down 1 over 3, so here I'm going to go down 1 over 3, and I have Q prime. Right, Q prime. Okay. And we can do the same thing again for P. 3 and 6. That one will end up right there. P prime. And finally, the same thing will happen with Q. So we see how, R, I'm sorry, R, didn't want to do that. A line, R, through the origin, and it will end up 5, 7. Right there. Okay, so make one more point, R prime, move my red line, connect my dots, and we have our 180 degree rotation. Now, if you hadn't guessed this already, there's also a nice little pattern to learn on this. Okay, for any 180 degree rotation, we turn XY into negative X, negative Y. I'll just show you the one here, but basically Q, we went from, what was it, 3, 1, and that made Q prime is going to come out being negative 1, negative 3. Sure enough, that's, sorry, negative 3, negative 1. Check that. I don't switch the order on this one. Negative 3, negative 1. Okay, that's our rule for 180. For 270, we could go through the same argument. I'm going to go this way, make a line, only now 270 degrees has me moving perpendicular down to here. There's Q prime, and P prime will end up down here, and R prime will end up over here. Okay, so connect my dots. Okay, so doing the same thing here, I'm just doing it all at once. We end up with our reflected image, 270 degrees. Right, our rotated image, right there where you see it. Okay, rule for the 270 degrees is that every XY coordinate changes into Y negative X. All right, and you can follow that one on your own. Finally, a 360 degree rotation, well, geez, it's just going to end up going all the way around the 360 degree circle and end up right back where we started. So it's going to turn out to be exactly the same as it started. The P prime, Q prime, R prime are exactly where P, Q, and R are. All right, so here are a couple to try yourself. Okay, pause, give it a shot, answer coming now. Okay, so we remember for any point, that's wrong. Negative YX, dang, typo here. Negative YX, change that, so it's correct now. Sorry about that. All right, so for any point, we use this rule, negative YX, XY becomes negative YX, and we end up finding that this is our rotation after a 90 degree rotation of figure ABCD. All right, that's all I got. You'll get to work on this plenty. I'll see you later.